Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and today we're continuing our deep dive into the fundamentals of concurrency. We're in the Thread Basics chapter, and our topic is Thread Priorities and Scheduling. Victor, are you ready to unravel this intriguing aspect of Java threading?
Absolutely, Sheila. I'm excited to explore this crucial part of thread management with our listeners.
Great. Before we dive in, let's start with a quick quiz for our listeners. Here's the question. In Java, what's the valid range for thread priorities? Is it A, 1 to 5, B, 0 to 10, or C, 1 to 10? Take a moment to think about it, and we'll reveal the answer at the end of the episode.
That's an excellent question, Sheila. It really gets to the heart of how Java manages thread priorities. Without giving away the answer, I think it's interesting to consider why Java might choose a particular range. Is it for simplicity, or does it relate to how operating systems handle thread priorities?
Those are great points to ponder, Victor. Now, let's start with the basics. Can you explain what thread priorities are and why they're important in concurrent programming?
Certainly. Thread priorities in Java are a way to inform the thread scheduler about the relative importance of threads. It's like assigning importance levels to different tasks you need to complete in a day. The thread scheduler uses these priorities as one factor in deciding which thread should be executed next.
That makes sense. So, if I understand correctly, a higher priority thread is more likely to be chosen for execution than a lower priority one, right?
That's right, Sheila. However, it's crucial to note that thread priorities are just hints to the scheduler, not absolute rules. The actual behavior can vary depending on the underlying operating system and JVM implementation.
Interesting. Can you elaborate on how these priorities are set and what range of values they can have?
Sure thing. In Java, thread priorities are integer values. The thread class provides three constants: min priority, norm priority, and max priority. You can set a thread's priority using the setPriority method.
That's helpful. Now, let's talk about thread scheduling. How does the Java runtime actually decide which thread to run?
Great question. Java uses a preemptive, priority-based scheduling algorithm. This means that at any given time, the highest priority runnable thread is selected for execution. If multiple threads have the same priority, the scheduler uses a round-robin approach, giving each thread a small time slice to execute before moving to the next one.
That's fascinating. It reminds me of how a good manager might handle multiple projects, focusing on high-priority tasks, but still ensuring that lower-priority work gets attention. But I'm curious, are there any potential issues with relying too heavily on thread priorities?
Absolutely, Sheila. Over-reliance on thread priorities can lead to problems like priority inversion or starvation. Priority inversion occurs when a high-priority thread is indirectly preempted by a low-priority thread. Starvation happens when lower-priority threads are consistently denied CPU time because higher-priority threads are always available.
Those sound like serious issues. How can developers avoid these problems?
Good practices include using priorities sparingly and carefully, ensuring that high-priority threads finish their work quickly, and considering alternative synchronization mechanisms when appropriate. It's also important to design your concurrent code to work correctly regardless of thread scheduling.
That makes a lot of sense. Now, you mentioned earlier that behavior can vary depending on the operating system. Can you elaborate on that?
Certainly, different operating systems implement thread scheduling differently. For example, Windows has a more direct mapping between Java thread priorities and OS thread priorities, while on Linux the relationship is less straightforward. This means that the same Java code might behave slightly differently on different platforms.
Wow, that's an important consideration for cross-platform development. Are there any best practices for dealing with these platform differences?
Absolutely. The key is to not rely too heavily on specific threading behavior. Design your concurrent code to work correctly regardless of the exact thread scheduling. Use higher-level concurrency utilities from the java.util.concurrent package when possible, as these are often more predictable across platforms.
That's excellent advice, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. What's the valid range for thread priorities in Java?
The correct answer is C, 1 to 10. In Java, thread priorities range from 1, min priority, to 10, max priority, with 5 being the default, norm priority.
Thank you, Victor. To summarize today's episode, we've learned that thread priorities in Java range from 1 to 10 and are used to give hints to the thread scheduler. The scheduler uses a preemptive, priority-based algorithm, but the exact behavior can vary across platforms. It's important to use priorities judiciously and design concurrent code that works correctly, regardless of scheduling specifics.
That's a great summary, Sheila. And since this is the last episode in our Thread Basics chapter, let's quickly recap what we've covered. We started with creating and starting threads, moved on to the thread lifecycle, and finished with priorities and scheduling. These fundamentals are crucial for understanding how Java manages concurrent execution.
Excellent point, Victor. In our next episode, we'll be starting a new chapter on synchronization fundamentals, beginning with the synchronized keyword. It's going to be another exciting dive into Java's concurrency features.
I'm looking forward to it, Sheila. Synchronization is where things really start to get interesting in concurrent programming.
Indeed. And to our listeners, thank you for tuning in. If you're enjoying our deep dives into Java internals, please subscribe to the podcast and leave us a rating. Your support helps us continue bringing you these in-depth explorations of Java concepts. Until next time, happy coding.